Today we are going to find the refractive index of the material of the prism. Before going to the experiment, we will see what is the refractive index. When light falls on materials, depending upon the individual material, it changes the wavelength, velocity, etc. Right? So refractive index is the ratio between velocity of light in vacuum divided by velocity of light in the particular medium. So this is the solid prism. So all the sides are filled. We have hollow prism also. In that we have an opening here. Then we can put our material and we can find the same experiment, right? So since it is a solid prism, it is having three surfaces. Two are very well polished surface. The other one is the rough surface. So any phenomena related to light will happen only on these two polished surface. Let us move on to the experiment. We have a sodium vapor lamp, solid prism, a spectrometer and a reading lens are the basic apparatus required. First, we want to focus a distant object using this telescope. Once that is done, we have to adjust the slit. Using this knob, we can adjust the width of the slit. We can increase or decrease the slit width. So, then already the light is on. So we place the slit to the sodium vapor lamp. And we, using the screw, we adjust the slit width. Once the width is adjusted, we adjust the prism table and we need to place the prism. We need to find two quantities. One is the angle of the prism, another one is angle of minimum deviation. First one, we are going to find the angle of the prism. To find the angle of the prism, what we have to do is, we have to keep the rough surface facing us. So we have two polished and one rough surface. We have to keep the rough surface facing us. Okay. Then we can move the telescope. First to the right hand side and then to the left hand side. We have to take reading on both sides. Okay. At this particular point, we get the slit. Then we have to take the readings. This is vernier A and this is vernier B. So, for the reading reflected ray on the right hand side, we have to take the reading on vernier A and vernier B. Similarly, we have to move to the left hand side reading. So, we have to slowly scan the telescope to get the reflected ray. So, at this point, I get the reflected ray on the left hand side. If you take the difference, it will give you the twice of the angle of the prism. Since it's the triangle one, we know the angle will be 60. So we'll be getting the angle around 120. Like in the previous case, we take the vernier A reading and vernier B reading. So this is the way to find the angle of the prism. Once you find the angle of the prism, we have to find the angle of minimum deviation. For that, we have to keep the rough surface on either left hand side or right hand side. That's our choice. So if you keep the prism on left hand side, okay, the refracted ray will be falling on this side. So you have to follow that one. Okay. At this particular point, I get the refracted ray. Once I get the refracted ray, without disturbing the telescope, what I do is, I have to rotate the prism table. If the rough surface is on the left hand side, I have to rotate clockwise. If the rough surface is on the right hand side, I have to rotate anti-clockwise. In our case, it is on the left hand side, so I have to rotate on the clockwise direction without disturbing the telescope. So once I rotate the prism, the spectrum moves, the particular line moves, so I have to follow that one. So simultaneously I have to rotate the prism table clockwise direction, and similarly the telescope towards the right direction. So what I am expecting here is, at a particular point, the particular spectral line will be moving like this. At one particular point it will be coming backwards. But I will be changing or rotating the prism in the same direction, but the prism will move in the opposite direction. That point is called as the angle of minimum deviation. So I am not changing the rotation direction, but the spectral line or the refracted ray goes or returns back. So that point is the angle of minimum deviation. We are going to find that one. To check that one, we have to move the prism to the anti-clockwise. Then once again you try to move in the clockwise direction. So it retraces. This is called angle of minimum deviation. So we have found A. Once again we have to take the readings in the vernier A and vernier B at this position. After that, after the angle of minimum deviation position, you remove the prism, take the telescope to the slit. Now you take the reading vernier A, vernier B, and this difference will give you the angle of minimum deviation D. From these two angles, the refractive index mu can be found out by sin A plus D by 2 divided by sin A by 2. Thank you.